Alright, so we're now doing 3.5, dividing polynomials. So we need to go back and we need to think back to grade 10 and 11 when we were factoring and what our factors were telling us. So I want you to try and factor f of x equals x squared minus 7x plus 12, g of x equals 3x squared plus 13x minus 10, and h of x equals 9x squared minus 16. If you need to go back and review how to factor quadratics, you can look at my other YouTube videos on factoring quadratics. But remember, you can use any method. You can use grouping and decomposition, or you can remember the shortcuts and go straight to the factored brackets. So first of all, remember, we're thinking what multiplies x squared minus 7x plus 12. What can we multiply? First times last multiplies to 12 and adds to our middle term of negative 7x. So the factors of 12 that will add to negative 7 are negative 3 and negative 4. Now if we try g of x, we're thinking what multiplies to negative 30 and adds to a positive 15. So you're trying to think of what breaks down to multiply to get 3x squared. We can only use a 3x and a 1x. And then we have to think of how we can break down a negative 10 and get our middle terms to be a 13x with a 15x and a minus 2x. So when we break it down, we have our 3x and our x. And then when we have 10 breaking down, we have our negative 2 with our positive 5. So when we say 3x times 5, we get 15x minus 2x will give us our middle term of plus 13x. And finally, h of x equals 9x squared minus 16. We've got a difference of squares because each term is a square and we're subtracting them. So we can remember our shortcut that each term will be the square roots and then different signs. So our two factors will be 3x plus 4 and 3x minus 4. So we need to think, what do the factors tell us? Our factors are each a divisor and a quotient to give us our dividend, our original polynomial. So now let's think of different methods that we can do if we can't factor. We can think back to long division in elementary school. We divide the divisor into the dividend, place value by place value. Alright, so dividing the divisor into the dividend, place value by place value, and subtracting. So if I want to divide 735 by 3, I'm trying to figure out how many times 3 goes into each place value. So what do you multiply 3 by to get 7? We can multiply by 2 and get 6. We subtract 7 minus 6 and we get 1. Carry down the 3 from the tens place value. 3 times what will give us 13. We're going to try 4. 4 times 3 is 12. We subtract, we get a remainder of 1. Carry down our ones place value, the 5. We're saying 3 times what will give us 15? A 5. So 3 times 5 is 15 with a remainder of 0. So that tells us that with a divisor of 3, a dividend of 735, our quotient or answer is 245. So 3 times 245 will give us 735. But can we use long division for polynomials? Let's try one of the original problems. X squared minus 7x plus 12 divided by x minus 3. We set it up the exact same way. Our dividend goes underneath the division symbol and our divisor goes outside the division symbol. And we're thinking, what do we multiply? We can just look at our first term, multiply x by, to get each place value. So x times x will give us our x squared. We also have to multiply by the other term. So x times negative 3 gives us minus 3x. We subtract this from the line above, so negative 7x minus negative 3x gives us minus 4x. And our x squared terms cancel out. We carry down our 12, and now we're saying, what do we multiply x minus 3 by to get negative 4x? So we're going to multiply by a negative 4. Negative 4 times negative 3 gives us plus 12. Negative 4 times x gives us negative 4x. When we subtract this from the line above, we get a remainder of 0, telling us that the divisor of x minus 3 times the quotient of x minus 4 will give us our dividend, our original polynomial. Let's try another example. 9x squared minus 16 divided by 3x minus 4. I want you to try and do this one. Key thing, notice that we do not have an x middle term, so you need to keep the place held with a 0 coefficient. So go ahead and try this one, pause the video, and come back when you're done. Alright, so now we can see that when we divide it, we have our place value of 0x holding the spot, and we're saying 3x times 3x minus 4, so we get 9x squared minus 12x. Subtract that from the line above and you get a positive 12x. Carry down your minus 16, and now repeat. What do we multiply 3x by to get 12x? A positive 4. So positive 4 times negative 4 is minus 16. Positive 4 times 3x gives you 12x. Subtract that from the line above and you get a remainder of 0. So we can see that with our divisor of 3x minus 4, we get a quotient of 3x plus 4. But what do we do if we don't have a remainder of 0? Let's try this question. X squared minus 7x plus 12 divided by x minus 2. Go ahead, do the long division, and then we'll discuss how to write your answer at the end. So we can see as we go through and simplify, we end up getting a remainder of 2 at the end. So we can't just write our two factors of x minus 2 times x minus 5. We also have a 2 added on. So the answer to the division question will be written as our quotient x minus 5 with our remainder over the divisor. So we have 2 over the x minus 2 added to our x minus 5. Let's try this question. 4x to the 4th minus 3x squared plus 5x minus 1 divided by x minus 2. Pay close attention, there is no x cubed term, so you need to again hold the place with a 0 coefficient. So do this long division, pause your video, and come back once you've completed it. Alright, so you can see this was a long question, but we can see because we put that placeholder of 0x cubed in, we were able to continue on and get a remainder of 61. So our final answer will be 4x cubed plus 8x squared plus 13x plus 31 plus our remainder of 61 over the divisor x minus 2. So our remainder theorem states when a polynomial f of x is divided by x minus k, the remainder is equal to f of k, the number obtained by substituting k for x into the polynomial. So remember, if we look back at this question, if we were to substitute 2 into our original polynomial, we get a value of 61. So that's what the remainder theorem is stating. So f of x will be equal to our quotient times the divisor plus the remainder. That's another way to write the original polynomial is equal to your divisor times your quotient plus the remainder instead of having your remainder over the divisor equaling the original polynomial divided by the divisor. So you could see how the previous question took a really long time. Is there a faster way? The faster way is synthetic division, and that's where we only use the coefficients and we add straight down. But you have to be careful with that one because you don't have the variables with their orders or their exponents included. So you have to remember what you start with to then be able to reduce them by one exponent. So going back to that same question, 4x to the 4th minus 3x squared plus 5x minus 1, we're going to use our coefficients, but we need to have descending degree order. So we have to put in a 0 coefficient for any missing terms. when we're dividing by x minus 2, our k value is a positive 2. So that's what we're going to be putting in. So we start with our k value and then all of our coefficients written down. For synthetic division, we carry down our first place value and then we start multiplication. So 2 times 4 is 8 and we add straight down. 8 times 2 is 16 and we add straight down. 2 times 13 is 26 and we add straight down. 2 times 31 is 62 and we add straight down to get our remainder. So you can see we got the exact same polynomial at the end. 4x cubed minus 8x squared plus 13x plus 31 with a remainder of 61 over our divisor x minus 2. Let's try another one. Let's divide x cubed plus 2x squared plus 3x minus 1. Let's divide it by x minus 1 first, so a k value of positive 1, and then try the question again, dividing by x plus 1 with a k value of negative 1. So remember, our coefficients will be 1, 2, 3, and negative 1. So we can see that this will be our constant, our x term, our x squared term, and our x cubed term. So we start by carrying down the 1, and then we start our multiplication. 1 times 1 is 1, add straight down. 1 times 3 is 3, add straight down. 1 times 6 is 6, add straight down, and we get a remainder of 5. So we have a remainder of 5, a constant, an x term, and an x squared term. So x squared plus 3x plus 6 with a remainder of 5 over x minus 1 because our k was a positive 1. Let's try it again with a k of negative 1. So we set up our original question again with our coefficients and then we do the synthetic division. So now we can see that we ended up getting a remainder of negative 3. So we got a different answer when we plugged in a different k value. So now our quotient will be x squared plus x plus 2 minus 3 over x plus 1. Okay, so seeing when you divide by different divisors, you get a different quotient. So is it possible to find the remainder without completing the entire question? Okay, so think back to your remainder theorem. If we get a remainder of 0, then we know that you have all of the factors. And what does the remainder mean? So I want you to you're going to practice some questions from this section in the textbook. I also have a worksheet for you to practice. And then tomorrow we will go over long division and synthetic division again and do some more practice and answer any questions that you might have.